Welcome. In this session we will look at caching, an important technique for enhancing the performance of the Fraxes platform. We will discuss the essential role of caching in Legoz, and present some key features and benefits of caching data objects. Caching in Legoz involves temporarily storing frequently accessed data or computations in a high-speed storage location, such as Parquet files. This accelerates subsequent access and improves overall performance. Let's examine how it works. When data is cached, it is stored in a high-speed storage location. The query engine is notified of this change. There are two ways to create a cache in Legoz. The first is to create it manually within the application, while the second is to set up a cache schedule. A cache schedule is a strategy that outlines when and how caching should be performed. It aims to optimize the effectiveness of caching while minimizing resource utilization, ensuring that data remains consistent and dependable. The delta attribute is used to ensure that cached data remains fresh and up to date. By setting a delta, for example on invoice ID, on initial cache, all the data will be stored. Thereafter, all data greater than the delta attribute will be added to the cache on each scheduled cache iteration. A well-planned cache schedule is vital for system performance tuning and resource management, especially for applications and services that rely heavily on caching for efficiency. Legoz uses a cron schedule to manage cache scheduling. This allows for the caching process to be automated efficiently. Refer to the crontab.guru website if you require examples that indicate how to enter the required values for the cron schedule in Legoz. Caching is ignored on a single source data object where push is active. Instead of utilizing the cached data, all queries associated with that object are directly executed in Spark. Even if the data was previously cached for efficiency, the system performs the entire query in Spark to ensure that the most current and consistent data is used. The fact that Spark reprocesses the data rather than retrieving it from the cache means that the full computational workload is reintroduced, and this can have an impact on performance. Refer to the pushdown video for more information on working with multi-data source objects. When working with validated data objects that have been cached, the system modifies the data object name in the query to reflect this status. Specifically, the name used in the from clause of the query is appended with _chh. This suffix indicates that the system will retrieve the data from the cache, rather than reprocessing or fetching it from the original data source. Automatically updating the data object name in this way ensures that the system uses cached data for queries, and that the need for repetitive data retrieval or computation is reduced. Refer to the Optimized Data Objects videos for more information on how to use caching to build data objects effectively. Next, let's look at the impact on performance between a cached and non-cached data object. Fraxes has a distributed compute engine that executes all queries at runtime. Normally, the compute engine would look up the connection information for the entity, finding out where it needs to query the data. Where to query the data is stored in the metadata. When you instruct Fraxes to cache a data object, the system stores that a cache exists in the metadata. When the data object is requested by any service, Fraxes notifies the service that the query location is now the cache, rather than the live data source. In this example, we have chosen a data object that joins 12 separate entities from a single data source. Push is not active on the data object. When previewing the data object without having cached it first, the run results take approximately 12.6 seconds to display. To manually create a cache, click the Data Objects menu option. Filter for the relevant data object, and select the caching icon from the grid. The Data Configuration Caching modal will open. Scroll to the bottom of the modal and select the Cache Now button. Once the cache is created, the view name, last cache duration, last cache date, status, and error detail fields will be populated. The cache status field may display one of three statuses. In progress, if the cache is in flight but the cache duration is not yet populated. Created successfully or failed, in which case the error detail field will be populated. The system will use the newly created cache for as long as it exists. To remove the cache and revert to querying the data source, click Delete Cache. For demonstration purposes, we will not be deleting the cache at this point. Return to the Object Builder and validate the object. Note: the data object name is appended with _CHH to indicate it is cached. Close the query. Now select the Preview button for the data object. The Run window displays results in approximately 3.6 seconds, which is 1/3 of the time it took to run the uncached object. Thus, using the stored cache instead of querying the data source directly has significantly improved the performance of the data object. Now that you understand how caching works, let's discuss cache scheduling. The caching schedule system allows you to schedule data queries to run for specific data objects. The data is kept in the current memory of the system, making it easier and quicker to retrieve. This is what would be perceived as hot storage. By caching large sets of data, you gain the benefit of protecting your production system from constantly being queried, resulting in a more stable environment with less network traffic out of the production site or servers. Let's add a schedule to the object that was previously cached. Note that in this new example the manual cache has been deleted. In this example, a schedule is added to run every 30 minutes against a delta attribute of invoice ID. Remember, a delta attribute can be used to ensure that cache data remains fresh and up to date. By setting a delta, for example on invoice ID, the delta cache process allows you to add specific data for a request to the cache. This means that you do not need to read all data for the query from the database when the data changes, but only any additions to the data based on the delta attribute. Firstly, add a description for the cache. Select the relevant delta attribute if required. In our example, we will be using invoice ID. Note the help icon next to the schedule config heading, which provides some brief instructions on how to capture a cron schedule, with more detailed guidance available from the cron website. To add a schedule to be run at 30-minute intervals, add a value of 0/30 in the minutes field. The Save Schedule button will become active. Select it. Once completed, a schedule ID will be displayed. If a delta attribute is used as in our example, the max value field will be populated once the cache has run for the first time. The cache schedule will now run every 30 minutes and refresh the data. A filter was added to the object where invoice ID is greater than 70509. Note, when the object is previewed, the data confirms that the highest invoice record is that with an invoice ID of 70510. An additional invoice record is added to the underlying invoice table. When the cache schedule runs at the next 30-minute interval, it will pick up this new record and increase the max value on the schedule accordingly. When previewing the data object, you will note that this new record is also displayed in the Run window. In conclusion, caching in Legoz is key in reducing the need for repeated network requests to the original data source. Implementing an effective cache schedule ensures optimal performance, data consistency, and efficient usage of resources within the system. Thank you for watching. Catch you in the next one.